Hello everyone, welcome to my talk at FOSDEM 2022 at the Foojay Open Dev Room. I'm very happy to be here and thank you to Foojay and FOSDEM for the opportunity, and thank you all for taking your time to come and hear me talk. Today my topic is about benefits of Mqtt for IoT apps and beyond. So with that, without further ado, let me start. So my name is Mary Grygleski. I'm a senior developer advocate at HiveMQ. Previously, I was with IBM as a Java developer advocate for 3 years, little over 3 years. I'm based out of Chicago. I'm also a Java champion and president and executive board member of the Chicago Java Users Group. I'm also co-organizers for a few other IBM-supported meetup groups in the Chicago area. I have experience as a developer for about roughly 25 years or so in the Java space. I have specialized in more product and application design, development, integration, and deployment kind of experience in the open source, cloud, DevOps, and reactive Java space and distributed messaging systems. So here's today's agenda. I'll start by introducing you to the Iot Stack, and then talk about what is Mqtt, a bit of history about Mqtt, and the OASIS open standard behind it, and then the Mqtt 3.1.1 features, as well as the 5.0 features. Then we'll talk a bit about the use cases for Mqtt and the alternative protocols for IoT, and some benefits, and essentially to the benefits and strengths of Mqtt for IoT. And then if we have time, we'll get a bit into the demo. If not, I'll point you to where you can see me present every week on Twitch. So let's start. So from 30,000 feet, looking down, looking at this IoT stack, it's I found it to be quite confusing, I must say. When I first started, I'm kind of assuming IoT, Internet of Things, is all about devices, device-to-device communication, machine-to-machine kind of data exchange. Yes, it is true. But then also, at the same time, I was a little bit scratching my head when I saw that some of the meetup groups, actually they were talking about artificial intelligence, machine learning, and things of that nature. So that kind of piqued my interest. I was like looking a little bit further in, then I realized there's this IoT stack. The stack is just like anything else. It's just complicated, especially in today's world. First of all, when I first brought up about devices, this really is sort of like at the more bottom kind of layer of this stack. Because it relies on the actual physical devices, such as smart devices, sensors, actuators, embedded devices, all kinds, right? That are kind of machines, essentially, collecting data from where, we can actually get the data. Now, in order for these devices be able to communicate with one another, in here too, I have kind of like abstract out and group all of the layers within the OSI networking layer all into this communication protocols thing. So as you can see, this is where Mqtt will fit, right? But of course, within the OSI layer, Mqtt is really on the application, a higher level within the OSI layer. But then here it is on this IoT stack. I've like grouped them all into the same communication protocols because it really deals with the actual data transfer of these electronic signals that are being transferred, on that layer. So Mqtt is among everything else, but I would highlight Mqtt as the best, among the, if not among the best of all the IoT protocols that are out there. So I'll be spending some time talking about why. But here it is, right? Mqtt is among other protocols such as CoAP, AMQP, DTS, and XMPP. These are more kind of the application layer protocol for, kind of have folks that are using it for IoT. Now, these are not limited ones. I mean, we can have other protocols too, but I highlighted the ones that are more popular. And then on this level too, essentially too, we are relying on TCP/IP. So IPv4, IPv6, and 6LoWPAN. This actually is a low-powered kind of IPv6 kind of protocol. Bluetooth, GSM, Modbus, BACnet. These are among some of the other ones, protocols that are being used, And then if we kind of talk about IoT, communication protocols, essentially too, if we go a bit higher up, then they would be called the core platform. These are essentially making use of all of these communication protocols and make more sense, right, out of really providing more of a service in that case. So in this case, this is where IoT messaging middleware fits in, and that's where also is HiveMQ is able to provide is this messaging middleware kind of capability within this whole stack. And then among other core platform kind of functionalities such as protocol gateway, data aggregation, data storage, all of these are really core platform type of services that you can have. And then as you kind of look further up there, analytics platform, right, such as the services, reports, events, machine learning, stream processing, all of these are either processing data that's kind of generated from all of these devices, or machine learning. You're trying to get the data and take the data and basically make sense out of it, kind of performing an analytics on it. And then if you go one up to is really the cognitive platform. It's a bit more higher level than just the analytics platform because, for example, things like interactions, they are spoken, voice recognition, AI type of scenario, gestures, face recognition, all of these are like on more of the cognitive platform layer. And then if you go all the way up, that layer would be like what we kind of see today, the solutions layer. Consumer, such as home, lifestyle, mobility, entertainment type of applications. Enterprise, like ERP, marketing, sales, business operations, these are more enterprise type of applications. And then industrial, right, like manufacturing, connected cars, automotive, logistics, construction, you name it, it's out there, all of these heavier industrial type of application. So now then, let's take a look. What is MQTT? MQTT, again, on the communications kind of protocol layer, is a standard binary publish subscribe messaging protocol designed for fast and reliable data transport between devices, especially under very constrained conditions. And that's the key word, constrained conditions. Constraints include unreliable network, network connectivity, limited bandwidth, limited battery power, and so on and so forth. And very often we know too, if we have kind of just a cell phone, for example, they are small, and you want to have data being able to kind of get transfer, and you want to guarantee the reliability. So we need a protocol to kind of help us to do a better job of this kind of application. But let's kind of take a look too, first at a bit of the history. So MQTT, it stands for Message Queuing Telemetry Transport, and basically was invented in 1999 by an IBMer called Andy Clark and at the UK Research Lab, and together with his partner Alan Nipper from another company, that they actually invented the MQTT protocol. And at the time, they weren't doing it for device-to-device IoT because at that time there wasn't such thing yet, right? And so they were actually doing it because they were on a project to handle like oil pipeline data that they need to collect, that are like from using satellite transmission. And because of the limited bandwidth and very constrained environment, they needed a better protocol. So they invented MQTT. And then in 2010, MQTT 3.1 was opened as royal-free protocol. It's kind of pretty much, within like 10, 11 years, it became the, protocol for Internet of Things. And then in 2012, and that's when Mosquitto 1.0 from the Eclipse Foundation, open source, right, was released. And then HiveMQ came into the picture in 2013, and that's when HiveMQ 1.3 released and started implementing the MQTT protocol. And then in 2013, and that's when the OASIS technical committee is formed. Now, OASIS, as we know, is an open source kind of community-driven, open, community consortium, right? That governs a lot of the specifications that are in the market today. So then 2013 is when OASIS technical committee is formed for MQTT. And 2014 is when MQTT 3.1.1 got officially released. That's kind of the major release that's still kind of being heavily used and has all of the kind of core features that are kind of making MQTT such a powerful protocol for IoT communication. And then in 2018, as all of these things, we're like moving more towards this speed, more and more speed and cloud native kind of platform. That's when MQTT 5 kind of officially got released. And HiveMQ version 4 started supporting MQTT 5 in 2018, soon after that. Now, the MQTT Technical Committee, as I mentioned, it is an OASIS kind of govern kind of a specification. So currently too, if you look into the website too, you'll find that there are 9 companies that are involved, and look at this, right? ThinkStream, IBM, 9FX, Cisco, Solus, Microsoft, EMQ, which is a company based in China for EMQ, and then Software AG. And then we also have our HiveMQ. And also, too, wanted to point out Christian gets our CEO is a very active member of this committee, as well as Dominic Obermeyer, who is the CTO of the company. Both of them are among the and other founders too. They founded HiveMQ, and to this day too, they are still very active in participating in the committee. So let's kind of get a bit then into MQTT, the meat of it. So again, a quick overview. It is an IoT messaging protocol. It has 3 quality of service levels, and it also has a very powerful feature called retained messages. And then it also, too, another thing is really kind of powerful about this MQTT is that it supports like stateful and persistent sessions through actually is the implementation of the broker. Essentially, too, MQTT is the protocol, and the broker is what makes this happen. It's really the center, the crux of making MQTT works is a really good broker. And it's actually binary, and it also has very minimal overhead, too. So let's kind of get then into the basic features of MQTT 3.1.1. So first of all, I mentioned about publish, subscribe. So what is that, right? So again, just now I talk about the MQTT server, which actually it functions as a broker. So think of it that way. A broker is like a post office, right? For example, you need to mail a letter. You wouldn't be, let's say you are mailing out Christmas cards, or even let's say Valentine's Day cards, right? These days you can mail out like 10 or 20, a gazillion kind of cards. You don't want to go to every single person to deliver your card, right? So you go through a post office. So in some ways, the broker kind of functions like a post office type of feature in this particular case, right? So now, in order to communicate with the broker, we call whoever is kind of needing the service will be the client. So the client can be the publisher or the subscriber. Now, as such, a pub/sub system is when you're publishing the data, you generate data, you're producing the messages. And in this case too is that instead of sending directly to your subscriber, you're going through the broker. You basically pass it on to the broker and have the broker do its work for you for delivering of the messages to another client, the receiving side, the subscriber side or consumer side. Okay, so now in MQTT terminology is that there are sets of MQTT commands. So the basic ones are, for example, like connect, right? In this particular case, I'm kind of showing you the way it works. It's kind of like very basic step is you always have like command that gets sent over from the client to the broker. In this case, a connect. So then the broker will have to come back with an acknowledge. So it will be a connack kind of coming back to tell the sender that it has received, the broker has received something. Likewise, you also have a subscribe command too. So the subscribe from the client side, you tell the broker you're subscribing to a topic. So in this case too, the broker got the message, got this command, then it will go back, send back to the client and acknowledge, right? So it will be a sub-ack kind of command going back to the client. Likewise, then there's also publish, right? That's important, very important. Pub, sub, and then the connect. It's essentially the 3 main kind of like, bare bone kind of system that you need to have in an MQTT IoT application. So pub side also, if you publish a data, then you have to indicate that you need to acknowledge it. So there will be a pub ack going back from the receiving side to the sender side. So from the broker to the client. Now let's take an example on the right-hand side above me here. And so an example of such is kind of like temperature sensor. You need to you need to like collect some data. So you kind of have this temperature sensor set up as the publisher. So whenever there's new data coming in, it will get published and sent over to your MQTT broker. So the broker, what it does is that you send over the data, you need to kind of label this message by using what is called a topic. So the topic will indicate to the broker, okay, this is the topic. It's sort of like a label. So it's kind of like then on the receiving side, right? On whoever is interested, the subscriber will then have to subscribe. It's like you you, if you're interested in some messages, you subscribe to it. If you're not interested, you don't subscribe, so you don't kind of get all clogged up with unnecessary delivery of messages. But if you're interested in it, in this case, you want the information about temperature changes, then you subscribe to the topic. So whenever there's data in there, the broker will then distribute the messages for you over to the subscribers, right? Essentially subscribing clients. In this particular case, it can be a laptop, it can be a mobile devices, anything you name to, it can be the ones that's receiving the data. So this is what PubSub is in a nutshell. So let's take a little closer look at some packet information. So if you look at it, right, the packet, for example, your client is going to send a connect packet command over to the broker. So as you can see, there's client ID, clean session, and username, password, last will. All of these I'll go over shortly. But all of these two, it's only client ID and clean session are the required ones, as well as the keep alive. Everything else are optional too. So now in this case, let's kind of move ahead a little bit. When you have sent the connect packet over to the broker gets it, and then it has to send back, right, to the sender. Basically saying session present, and also a return code of 0, indicating that, okay, it's successful, I got it, kind of like that. So, okay, now then you've seen that there are a couple of fields that are optional. They are called last will, topic, last will, QoS, and all these things. So what is last will? Think of it's kind of like a person, right? Essentially too, it's basically, it's the client, right, who defines the will. So it's essentially last will and testament, LWT. So the broker will send this message on behalf of the client in the event that the client dies. And that's what it means, right? So it's basically the client, when you send the packet, you have to kind of indicate what topic it is and what quality of service level it is and what message do you want to send, right? If kind of something dies, what do you want to send? It's essentially last will. And so in this case, the message won't be sent if the client doesn't die. But essentially, too, it's sort of like a backup, right? If something goes wrong, okay, then the broker will then push the message over to all of the recipients and indicating that the client had died. So this is a special feature of MQTT. And now we already went through the publish subscribe, but let's take a really quick look at the packet level too. So on the publish side, you see that there's packet ID that identifies that sending the message that's been sent, and the topic name where the message should be going to, and the quality of service flag, which is guarantee, what is the level of guarantee for this message delivery, and then the retain flag, right? Do you want to retain it? And I'll talk about that in a second. And then the payload, what actually do you want to send over? And then dupe flag is essentially too is false. First time you send is always false. And also it depends too. If QoS is 1, it can actually be resent too. So that I will discuss a little bit. Now on the subscribing side, as you can see, the subscribing packet too can be referring to the same packet, but you actually can have multiple topic subscription within the same packet too. And in this particular case, we have multiple topics, topic 1, topic 2, they each have specified different levels of QoS as well. And now then let's take a look at retained message. So retained message is essentially the last known good value. So basically too, this is what it means is that essentially after you deliver a message, if the message, as indicated by the client that needs to be retained, if you recall the retain flag, if it's been set to kind of yes, kind of essentially turn it on, true, right? And then basically you're telling the broker, okay, don't kind of just discard it, save the last known good value. That will be sent, and when future clients wants to get, when they subscribe to the topic, they will get it too. So in some circumstances too, for example, you want to have things kind of being done quicker. So basically too is that, I know I'm the client, I'm subscribing, and I want to make sure that this message gets sent to all of subsequent future subscribers too. So that's what it is. So the benefits of such is that you save the time, because if another client comes in, once I actually have the message ready, the broker, without even asking, will kind of basically send the message over to future clients. So it will be kind of like saving a bit of time. So then kind of initial state doesn't need to be initialized with that extra, bit of, even though, okay, it's nanosecond, but it saves time, right? Because you can have messages that are, in the billions or like, even like, like huge kind of sending too. So you want to have this kind of efficiency achieved at every level. Now, let's take a look then at the quality of service that I talked about earlier. This actually is a really key features of MQTT, and that's what makes it like so robust, right? Now, in any kind of environment that's kind of constrained, right? You don't have enough batteries. The batteries can go dead, while you're delivering the message, and message is kind of like in transit. And then the network can go down, right? A lot of times too, we as programmers too, especially, we feel that we program as though the network is kind of like, invincible. It won't die. But guess what? Network is never reliable. So QoS is absolutely important. So QoS is 0. So it means at most once delivery. QoS 2, as you can see, right, there's like one pair of kind of handshake is send and then receive kind of an ACK. At least once delivery for QoS 1. And the thing is too, there's this need for exactly once delivery, no more, no less, so that you want to use QoS 2. As you can see, there are like 2 pairs, right? Like 4 kind of like sets of send and receive kind of a handshake kind of command going back and forth. So let's take a little bit of a closer look. Quality of service 0. So if it's 0, it essentially means fire and forget. So you might wonder, well, why do I want to do this? It is very true. As such, right, even the packet ID will be 0 because there's no need. It's more like a best effort kind of guaranteed delivery. I don't care. It almost seems like sender says, I publish the message. Even if it doesn't get received, I don't really worry about it. It's just up to whatever. Kind of like that. So it doesn't guarantee, right, the delivery, but the thing is too is that it's very fast. It just send and forget kind of thing. So you just specify topic name and the QoS level is 0. Retain flag is obviously also kind of, I think it would be like false. I guess you can also send it to retain if you want to, right? But there's really, it really isn't on this level. And then payload will be like a, kind of a, your actual message you want to deliver, and dupe flag, it would always be false in this case. So now, quality of service is 1. So this one is actually has a bit higher kind of guarantee, right? So as you can see, I'm doing a publish, my MQTT client, I do a publish, QoS 1. So I have my packet ID, everything, and gets sent over to the broker. Now, there's a timeout value too, but if it kind of like within the timeout, it hasn't timeout yet, the broker received the message, then it will send back an ACK. So a pub ACK kind of indicating the packet ID. So then the sender will know, okay, you receive it. And then, they can do whatever they want with the message, knowing that, the broker already got it in this case. Now, with this particular level too is interesting because that will mean that, if you get timeout, right, then basically the publisher, the client can then resend this message. And in that case, then the client will then have to turn on the dupe flag, indicating it is a duplicate message. Now, you could be like sending so much, so then actually on the receiving side, you can receive multiple messages too. It is possible like that. And basically too, this kind of usage scenario is when you really don't worry so much. Maybe you're doing some sort of cumulative kind of data that you're collecting, and even if you have sent duplicate, it may not affect the outcome, that type of scenario. So the nice thing about this level is that it's slightly faster than the QoS 2 that I'll be talking about next. So quality of services 2. So as such too, as you can see, right, there are like a pair of kind of 2 pairs of kind of back and forth kind of messaging. So if you take a look at the packet, the first time the client will send the packet over to the broker, and you have indicated the packet ID, topic name, retain flag, all of these things, and QoS 2. So the first time you send the message over, the broker gets it, then the broker will then comes back with kind of a rec, is essentially like a recording, kind of receiving, right? Sorry, pub rec, and it's indicate the packet ID. So in this case, then the MQTT client will then, the sender, right, the publisher will make a note with saying that, okay, cool, you got it, that's great, right? Then it can be the publisher or the subscriber too, actually. So in this case too, then the client will then send another packet over with the same packet ID, indicating to the broker that, okay, I got it now. So I know that it is very important because then it will guarantee only once kind of delivery in this case, because my client already got the pub receipt in this case. Then it will send back to the broker and said, okay, the broker then will get the message and said, cool, very cool. Now I got it. Then let me send you back the pub com, which is like complete and indicating to the client. So in that case, then the client will then say, okay, all done, I'm all done, and I'm not going to send any more messages. There should not be any more duplicate in this case. So okay, so now then let's kind of take a look, right? We're talking about MQTT 3, but how about MQTT 4? So the quick thing about this is that in the connect message packet detail for MQTT 3.1.1, you see that there's a field called version. That version is 4 for 3.1.1. And then so when MQTT 5 comes along, then basically too, the version has been up to 5. And so they decide to kind of coincide it better with version 5 with the version 5 and of MQTT. So that's why there's no MQTT 4. And now let's kind of do a really quick thing into talking about MQTT 5. So basically, MQTT 5 is a successor of 3.1.1. It has non-backward compatibility. First public release was in January 2018 and official release in 2019, so a fairly new one. Many new features and clarifications of the 3.1.1 specification. Basically, too, the crux of it is with scalability and large-scale systems. It has improved error reporting and formalized common patterns, including like capability discovery and request response type of capability. Now, mind you, the request response isn't the same as something like HTTP. So, and extensibility mechanisms, including like user properties, so you can define like in your metadata header too you can have additional user properties, giving you a better way of kind of doing any kind of like configuration stuff. And then performance improvements and support for smaller clients. And some key new features. I'll kind of go really fast over this now. So session and message expiry is one of the ones. Basically, broker will expire session after the given interval as soon as the client disconnects. So essentially, giving you a bit more control over the timing of these messages, how long it can be kept, and the expiration side. So user properties, as I talk about, it can be part of most MQTT packets. It can be on con, connect, pub, and sub, user-defined metadata headers too. And share subscription, this particular feature is actually very interesting. HiveMQ actually came out with this feature before MQTT 5, and then that became a standard after HiveMQ has kind of provided this capability in the HiveMQ 4. So as you can see too, it's basically, it helps for client load balancing. Multiple clients can share the same subscription. So let's kind of take a look too. Is again, I wanted to point out it is a optional feature, so not all vendors will be kind of providing these features too. So, but I want to kind of point out HiveMQ has this feature and it's very powerful. So in this particular case, you can see that a topic can actually be shared among different subscribing clients too. So in a cloud native Kubernetes type of environments, actually this is proven to be very capable, very powerful features. So that's something I want to point out in MQTT 5. Okay, the request response pattern is not the same, right? As I mentioned, it's not like the request response of synchronous client-based, server-based protocols like HTTP. But I want to point out that this particular request response is to help with correlating your header, that correlating the request and the response. So sort of help out with the correlation data kind of pattern for business X kind of usage scenario. Okay, so in this particular case, a picture is worth 1,000 words. So as you can see too, you publish the message, right? And then it comes back with the return message and everything. But as you can see too, on the business level too, you can actually make some correlation because of this request response type of functionality. So. Okay, so this, let me kind of get then in the last 5 minutes or so now. So I wanted to point out to why MQTT is so kind of preferred, right? So you can see it's a lightweight and bandwidth efficient protocol. It's basically, you look at the MQTT control packet. I wanted to point out protocol headers are very small in size. Basically, the fixed header is only 2 bytes. And you can have up to 12 bytes for variable header and variable size, and they are present only when needed. So if you don't need it, it's actually not even being used. So this variable header, essentially too, the control packet has the fixed header, variable header, and the payload. So as you can see, extremely lightweight kind of message structure. And it's also data agnostic. That's a nice thing too. You can send all kinds of data, images, right, blogs, and text in any encoding format. Encrypted data is essentially a binary data protocol. And also the continuous session awareness too. You can have persistent sessions. So essentially the broker, again, is the crux of everything. It takes care of things, if the client goes down, you need to retain messages. You need to kind of persist all of these kind of messages. If client is dead, they kind of bounce back. You need to have somebody to take care of these things, right? The last will, all of these things. So essentially the broker is what kind of gives kind of like the big power in doing IoT type of messaging. And imagine too, you can have many messages being connected to the broker, and the broker will sort things out for you, so you don't need to worry about it. So that's why it's very useful in an IoT kind of scenario, especially over unreliable networks. Use cases for MQTT are like IoT, industrial IoT, like Industry 4.0, that kind of encourages interoperability among many different types of libraries, frameworks, and systems. And IoT is perfect as a messaging protocol. Industry verticals are already pointed out, right? Automotive, logistics, manufacturing, energy, consumers like your smart home, your wearables, alarm system, car alarm system, anything you can think of. And integration with other frameworks too. For example, MQTT can integrate very well with other streaming platforms such as Apache Kafka. In HiveMQ, we have extension SDK that's actually really works powerfully in kind of an enterprise kind of scenario. You can be collecting data on the IoT kind of front end and then pass through to the Apache Kafka for more of an enterprise kind of heavier processing in the back end too. And then other MQTT brokers that such as Mosquitto, such as Apache Vern, all of these other things, you can actually integrate HiveMQ, any kind of brokers together to working together, in a very kind of cohesive kind of coherent pattern too. And runtime such as Spring Boot for HiveMQ, we also support too. So, and we want to kind of try to achieve these IoT scales is 2.7 billion publishes per minute, 100,000 topic subscriptions, and many connected devices, in up into 100 billion kind of scale on that level, and 100,000 queued publishes for one queue too. And in summary, right, this is PubSub MQTT protocol, asynchronous, loosely coupled, very lightweight, can operate in a constrained environment really well. In unreliable, high latency networking environment, ideal protocol for IoT use cases. And I want to encourage you all to try out our HiveMQ Cloud. It looks like then I may not have time to get into it, but please visit this link or kind of I'll be sharing these slides so you can kind of take a picture of the QR code and get to our MQTT client cloud broker. Let me kind of quickly kind of show it to you. So if you go to our HiveMQ.com, go to the cloud and HiveMQ. This is how you can sign up now. There's a free tier access that doesn't cost you anything. And you can also try out our kind of a public broker to kind of just get a sense of how do you make a connection, how do you publish and subscribe to. So that would be something that I would like to kind of encourage you to give it a try. So, okay, let me kind of go back in here. And please, today I cannot do the demo, but please follow me on my Twitch stream. I stream usually, right, every Wednesday at 2 p.m. is U.S. Central Time, but they will be recorded too. But of course, I love if you can join me live and interact with me. This would be my Twitch TV kind of URL. So. And then these are some of the resources. MQTT at Oasis, get started with MQTT. MQTT Essential Series is a really good kind of comprehensive overview to help you to get started with MQTT. Please evaluate HiveMQ and also try out our HiveMQ Cloud. If you have any questions, let me know. And this is how you can get a hold of me. I really want to thank you again for you having sat through my talk. I hope this has been helpful to you, and please stay connected and follow me on Twitch and also try out our HiveMQ Cloud. Thank you.